A median is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. A is a vertex, E is a midpoint. I can see it's a midpoint because it's got this side cut into two equal parts. So segment AE, pick up one of each, is a median. The reason it's important to know this definition is sometimes they're going to tell you something's a median and they're not going to have marked the picture with which pieces are congruent. If you know the definition, then you're going to know that it intersected at the midpoint, and you're going to know then those two pieces are going to be the same. So here's an example. It says EG is the median. And the minute I see that word, what should I do down in my picture? I should mark that G is a midpoint by marking these two pieces as being congruent. It says find X and DF, so I'm looking for two things. I'm looking for X and DF. If DG is 4X minus 1, and GF is 2X plus 5. Well, because this was a median, what can I do with these two pieces? Set them equal to each other. 4x minus 1 is equal to 2x plus 5. Subtract 2x from both sides. 2x minus 1 is equal to 5. Add 1. 2x is equal to 6. Divide by 2. X is equal to 3. Now that's part of what they asked me to find. What am I going to do with this 3 now that I know x is 3? Plug it back into this picture. I have 2 times 3, which is 6 plus 5. This segment is 11 units long. How big is this segment? 11 units long. So how much is DF? 22. So it's important to know what the word median is, because if you don't know what median is, then you don't know to set these two pieces equal to each other. Questions on this first example? How many medians do you think a triangle has?
3.
Does have 3. And they're going to meet at a particular point. And the point of concurrency of medians of a triangle is called a centroid. And I don't know if I talked about this yesterday in this class, but if I did, I misspoke. I said the in-center was a balancing point, but a centroid is actually the balancing point. If you cut a triangle out of cardstock, something that was a little stiffer than a piece of paper, and you found the point of concurrency of the medians, that triangle would balance on your pencil point. It is the balancing point of a triangle. The centroid theorem says the distance from the vertex to the centroid is double the distance from the side to the centroid. Well, let's look at what that means. Q is the centroid, and we're going to just make sure that you can see that it is by making sure that each one of those points on the side is a midpoint. So make sure that you mark the triangle. On the side where AB is, mark AF and FB with 1 mark, BD and DC with 2 marks, AE and EC with 3 marks, which makes Q a centroid. It says the distance from the vertex to the centroid, well, from B to Q, is means equal, double 2 times the distance from the side to the centroid, which would be from Q to E. So BQ, whatever it is 2 times of what QE is. The same thing would happen here. CQ is going to be 2 times of what? QF. And AQ is going to be 2 times of QD. If I told you that this one was 1, then up here would be 2. If I told you that this one was 4, then up here would be twice as big, or it would be 8. If I told you that this one was 8, how would I find this one? Instead of multiplying by 2, I would divide by 2, so this would be 4. Okay? The distance from the vertex to the centroid is twice the distance from the centroid to the side. Again, important to know what a centroid is, because if it tells you it's a centroid, then there are some things that you know. You could mark the midpoints of the sides. That might be needed. It's not in this problem. But you could mark it once you see that it's a centroid. It says in this case, BE, the whole thing is equal to 9. Do we know how big QE is? If I don't know how big it is, what would I put there? How about a variable? If I call this x, how big would this one be? Not x2, but what? 2x. Well, if I take 2x and I add x to it, it should be equal to the whole segment, which was 9. 2x and x is 3x, which means x is equal to 3, which means QE is 3, and BQ then must be what? 6. It's twice as big. And 3 plus 6 is 9. Questions on example 2? In example 3, it says Q is a centroid. Again, if it's a centroid, I'm going to go ahead and mark the midpoints of the sides of the triangle. It said Z to Q was 11. This is 11. Well, I know ZQ is equal to 2 times that of QR. But ZQ was 11. How would I find what QR is? How would I get QR by itself? Divide by 2 and it'd leave me QR is equal to 5.5. Questions on either one of these two examples? Yep. Mm-hmm.
DQ equals 2QR.
Mm-hmm.
How did you actually do that?
How did I know that?
Yeah, like the two part.
Because the theorem says the distance from the vertex to the centroid is double the distance from the centroid to the side. So if I come back here, from Z to Q, the vertex to the centroid, ZQ, is twice that from the centroid to the side, which is QR. We good? Other questions? Altitude. Altitude is a segment from a vertex perpendicular to a line containing the opposite side. And it is important that you notice that it says that it's perpendicular to a line containing the opposite side, and you have to understand that not all altitudes are actually on the inside of a triangle. This one is on the inside. However, if I drew an obtuse triangle, and I wanted to look at the altitude of this triangle could be on the outside of the triangle, because it says it's perpendicular to the line that contains the opposite side. Well, this would be the line that contains the opposite side, so this would also be an altitude. This one's on the inside, this one's on the outside, and it's also possible that the triangle could be a right triangle. And if it was a right triangle, then this and this would both be what? They'd both be altitudes. Now, if you happen to be working with a formula for the area of a triangle, it says 1/2 base times height. Height and altitude are interchangeable in a triangle. This is the height of the triangle. How many altitudes do all triangles have? There's actually 3. You can draw an altitude in from any of the vertices. There's 2 right here. I could draw in a third one. There's 1 here. I could draw in 1 here, and then I could draw the other one in, and I don't know where it would come to. From here to be perpendicular, it would probably be something like that. So there is 3 in all of them. Again, the importance of knowing the definition is, if it is an altitude, it tells me something about how it intersects the side of a triangle. If it's an altitude, what type of angle does it make? It makes a right angle. They don't always mark it in the picture, but the minute you see that word, you should take the time to mark it. And here they're saying angle KTJ. KTJ. TJ, this angle, they're saying is 7y plus 6. Well, what is 7y plus 6 going to be equal to then? 90. We're going to subtract 6 from both sides. 7y is equal to 84. And we're going to divide both sides by 7. And y would be equal to 12. Pretty good? This is not on your note-taking guide, but please take the time to write it down. Why it didn't print, I don't know. It just missed. The line that contains the altitudes of a triangle are concurrent at the orthocenter. And they're showing you that in an acute triangle, that the orthocenter is on the inside. That in a right triangle, the orthocenter is on the triangle. And that if it's an obtuse triangle, oops, go back. If it's an obtuse triangle, the orthocenter is on the outside of the triangle. The ones that we've talked about over the last couple days. If you're talking about the point of concurrency of the perpendicular bisectors, it is the circumcenter. It is equal distance then from the vertices of a triangle. Angle bisectors, their point of concurrency is the incenter. It is equal distance from the sides of the triangle. The point of concurrency of the centroid, of the medians, is the centroid. These don't create things that are equal. The distance from the vertice to the centroid is twice the distance from the centroid to the side. The point of concurrency of the altitudes is the orthocenter, and the biggest reason that this one's important is if they tell you it's an orthocenter, then you know that all of these angles had to be 90-degree angles. And your assignment for today is to do that worksheet.